So my name is Dr. Danny Elvidge and I'm Senior Lecturer in Building Physics and Services at the University of West of England in Bristol, and I'm making this video to teach you about trigonometry and Pythagoras. This video is split into 4 sections. The first section is an introduction, and I'm going to introduce what I call the triangle toolbox, which will enable you to answer any questions you're faced with when talking about right-angled triangles. Then we're going to move into Pythagoras Theorem, then talk about trigonometry, and then finally I'm going to give some examples of using this maths in a workplace environment. So this is an introduction to Pythagoras Theorem and trigonometry. It's an area of maths which is often made far more complicated than it needs to be, so I hope that by the end of this you'll have a clearer understanding of how to work with right-angled triangles. A right-angled triangle is any triangle which contains a 90-degree angle between two of its sides. So a right angle. And these are solved using Pythagoras Theorem and trigonometry. Pythagoras Theorem is often referred to as a squared plus b squared equals c squared, and trigonometry is summarised with the rather strange word Sohcahtoa. This a squared plus b squared equals c squared is often referred to as the Pythagoras or Pythagorean theorem. And what it talks about is the relative lengths of the different sides of a right-angled triangle. The only thing you need to remember when using it is the long side of the triangle, otherwise known as the hypotenuse, is C, and that's always the case. The hypotenuse, the long side, is always C. A and B can be either one of the other two sides. It doesn't matter, the math still works. So let's give an example. Here is a simple right-angled triangle. And here is the right angle. We know that the hypotenuse, the long side, is always C. And in this case, this triangle is 3 by 7. Now that could be 3 centimetres, 3 millimetres, 3 metres, it doesn't matter for the maths. In this case, I'm going to make it 3 metres by 7 metres. The question now is, what is C? Well, let's use the Pythagoras theorem. That is a squared plus b squared equals c squared. Well, we don't need to find c squared, we need to find c on its own. So what we're going to do is rearrange this equation so that the square root of a squared plus b squared equals c. And if you're unsure as to why I've done that, I've made a separate video on how to rearrange equations, which should make things clearer. Now we can start plugging in some numbers. It doesn't matter which one of these sides you label as a and b. It only matters that c is always the longer side. So in this case I'm going to make a the 3 metres and b the 7 metres, but the maths will work with the other way round. So now let's put in the numbers. The square root of 3 squared plus 7 squared equals c. So now we start to solve the equation. We know that 3 squared is 9, you can check that on your calculator, plus 7 squared is 49, the square root over that equals c, which means the square root of 58 equals 7.61. So c equals 7.61 metres. So that's the first half of the maths you need to solve questions about right-angled triangles, Pythagoras theory, otherwise known as a squared plus b squared equals c squared. Now let's look at trigonometry, and this has the rather complicated word behind it of Sohcahtoa. So you can solve most of trigonometry problems with the term Sohcahtoa. Now this is a difficult word to remember, but there are various ways of remembering it by using mnemonics. One of the ones you can use is saddle our horses, canter away happily to other adventures. So Sohcahtoa. And if you can remember that sentence, you can remember Sohcahtoa, and therefore you can unpack that to do your trigonometry. Other ways of remembering Sohcahtoa are: sense of humour can always help to overcome awkwardness, some old hippies caught another hippie tripping on acid, and sex on hard concrete always hurts, try other alternatives. Let's look at trigonometry. First of all, we need to write down Sohcahtoa. How does that relate to a triangle? Let's draw a simple right angled triangle. Now remember, it's called a right angled triangle because that is 90 degrees. That's your right angle. In every case, the longest side of a right angled triangle is called the hypotenuse. And in Sohcahtoa, the H stands for hypotenuse. But what are the other two sides of the triangle called? Well, on a triangle, the other two sides are called the opposite and the adjacent. And which is opposite and which is adjacent depends upon what angle in the triangle you're looking at. So if I'm looking at this triangle, say this is a slope and I know that that angle is 5 degrees, the side opposite that angle is the opposite. And this changes. If I was looking at the angle here, this would be the opposite. So it's whatever side is opposite the angle is known as the opposite of the triangle. Now this only leaves you with one side of the triangle left, and that must be the adjacent. Now remember, if I was looking at the angle here, that would be the opposite, and therefore the only side left unlabelled would be the adjacent. So now we have the hypotenuse, we also have the opposite part of Sohcahtoa and adjacent. Now that just leaves us with the S, the C and the T, and those are mathematical functions called the sine, the cosine and the tangent. It's the sine, the cosine and the tangent that will enable us to calculate the angles in this triangle. I think it's going to be simpler to explain that by unpacking Sohcahtoa so that all of the equations are shown for this triangle. This is what I mean by unpacking Sohcahtoa. Sohcahtoa, it contains all of the maths you need to solve trigonometry. You've just got to remember that one phrase, and then you'll be able to write down all of the equations you require and how you can rearrange those equations. Let me explain. First, write Sohcahtoa. The next thing you need to do is write out the phrase, but this time raise the middle letter of each part of So, Ka and Toa. So S, O, H with the O higher up. C, A, H with the A higher up. And T, O, A with the O higher up. Next, underneath each one of these, you can draw a triangle. And you can write the letters in the triangle. So S, O, H, C, A, H, T, O, A. Earlier we talked about how the H stands for hypotenuse, the A stands for adjacent and the O stands for opposite. But the S C and T stand for three different mathematical functions. S stands for sine. Sine, the angle that you're looking at. In this case, for this triangle, the angle is there because that is the opposite. C stands for cos, the angle, and T stands for tan, that angle. Each of these equals the relationship between the lengths of two other sides. So sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. And can you see how that's set out above in the triangles? Sine S equals opposite O over hypotenuse H. S O H. S O H. C equals adjacent over hypotenuse. Cos equals adjacent over hypotenuse. And tan equals opposite over adjacent. So now from Sohcahtoa you've written it out in this way, and that has shown you how each of these two lengths is represented by the mathematical function tan, cos or sine of the angle that you're looking for in the triangle. So let's run through that again. You started off with a right-angled triangle, and you know that the longest length of a right-angled triangle is the hypotenuse. You know this angle, which means this side opposite the angle must be the opposite, and then the only side left over must be the adjacent. Next, you wrote out Sohcahtoa, which you remembered from one of the silly phrases earlier. After that, you raised the middle letter of each part of Sohcahtoa, which enabled you to write these triangles. These triangles contain S, C and T. And S, C and T stand for sine, cosine and tangent. These are the mathematical functions of the angle which relate it to the lengths of the other two sides. So then you can write out sine theta, which is the angle, equals opposite over hypotenuse. Cos theta, the angle, equals adjacent over hypotenuse. And tan theta equals opposite over adjacent. And that's all the maths you need to solve right-angled triangles. Here's an example. Here is a right-angled triangle. There's the right angle. We know that the longest side is always the hypotenuse, and we want to find out what this angle is here, knowing that this side is 8 meters long and this side is 5 meters long. How do we do that? Well, first we've got to label the opposite and adjacent. Here's the angle, therefore this must be the opposite, and the opposite equals 5 meters. The only angle left over must be the adjacent. The adjacent is 8 meters. How do we find out what the angle is? Well, first let's write down Sohcahtoa, and then unpack it as we did earlier. So that's Sohcahtoa unpacked. We now have all the maths we need to find that angle. Let's do it. So we need to find that angle. What information do we have? Well, we don't have the length of the hypotenuse. We have the length of the opposite and adjacent. So which one of our equations here has opposite and adjacent in it? This has opposite hypotenuse. That can't be it because we do not have the hypotenuse. This also has hypotenuse, so that can't be it. This, therefore, must be the equation that we're going to use. So the equation we have is tan theta equals opposite over adjacent. And we need to find theta. So we need to get theta on its own. So tan has to go on this side of the equation. To do that, we're going to use the inverse tan, so the opposite of tan. If you want to know why we're using the opposite, I've made another video explaining how to rearrange equations. So now we have theta equals inverse tan, which is written tan minus 1. I'll show you this on a calculator in a moment. With the opposite over adjacent. Let's put in the numbers. The inverse tan, the angle equals the inverse tan of 5 meters divided by 8 meters. Let's put that into a calculator. I need the inverse tan, so I press Shift and then the tan button, and you'll see there's the tan minus 1, inverse tan. 5 divided by 8, close the brackets, equals 32. So that's 32 degrees. The angle in our triangle is 32. Let's look at another example. In this case, we know the angle here is 6 degrees and this length is 5 meters, but what is that length? Start by writing in hypotenuse. You always know this is the hypotenuse, and we know that this is opposite, so now we know we're looking for the opposite, and we know that the adjacent is 5 meters. Let's unpack Sohcahtoa. How do we use trigonometry to find the opposite? So, which of the equations can we use? We're looking for an equation with adjacent in and opposite. So it can't be the first. This is adjacent hypotenuse. It can't be the second. So it must be this. This equation says tan theta equals opposite over adjacent. But we need to find opposite, so we need to rearrange the equation. And this is where the triangles we've drawn become really useful. Because if you look at the triangle, just drawing it here again for clarity, tan, opposite, adjacent. If we want to find opposite using the triangle, it's opposite equals tan times adjacent. So it's opposite equals tan theta, the angle, times adjacent. So let's put in the numbers. It's tan 6 times 5, which if you put that into a calculator comes out as 0.52 meters or 52 centimeters. And this is how you put it in a calculator. So we want to find opposite, which is tan 6, close the brackets, times the adjacent, which is 5 meters, and that gives us 0.52 meters or 52.5 centimeters. In summary, when you understand Pythagoras and trigonometry, you can solve any problems you come up with right-angled triangles. Just remember that on a triangle, the longest side is always the hypotenuse, or c in the case of Pythagoras Theorem. Remember that a squared plus b squared equals c squared. Remember Sohcahtoa and how to unpack that to show the various equations you see below. Let's look at some examples. In this case, you've been asked to design an access ramp. The gradient must be 5 degrees and it must rise 1.7 meters. What's the horizontal distance? How far does this ramp come out? First of all, let's draw the problem. You have a ramp. It's 1.7 meters tall and the angle is 5 degrees. Next you label up your triangle. This is the hypotenuse, the longest side. This is the opposite, as it's opposite the angle, and this is the adjacent. We can unpack Sohcahtoa, select the correct equation, that is the one with the measurements for opposite and adjacent, so not that, it must be that. Rearrange that equation so it's the adjacent is the subject, so that would be adjacent, there is the opposite, there over tan theta, and then plug in our numbers. The opposite is 1.7 meters, that is over tan of 5 degrees, and that will give you an answer of 19.43 meters. In this example, you have the lengths of two of the sides, but not the angles. So how do we carry out this calculation? So we have a 3 meter long scaffold plank is being used to build a ramp up to the skip. The side of the skip is 120 centimeters high. How far does the ramp reach out? Let's draw our problem. Here is the side of the skip. Here is our plank, and here's the ground. This is a right angled triangle. We know that it's 120 centimeters tall, otherwise 1.2 meters. We know that the plank is 3 meters long. Now we have to find the length of this side. Now we don't have an angle in this case, so we can't use trigonometry. We have to use Pythagoras Theorem. And that is that a squared plus b squared equals c squared. We know that the hypotenuse, the longest side, is always c. The other two sides can be allocated as a or b, it doesn't really matter. In this case, I'm going to call this side we're looking for a and this side b. So we are rearranging Pythagoras' theorem to find a. A squared plus b squared equals c squared. And that's the same as saying that a squared equals c squared minus b squared. But we don't want a squared, we want a on its own. So that means that a equals the square root of c squared minus b squared. So let's put in the numbers. That means that a equals the square root of 3 squared minus 1.2 squared. That's 1.2 because we are keeping all of our measurements in meters, which gives us an answer of 2.74 meters.